Good morning. I would like to sit here and verbally go over the final version of the commercialization plan I just produced, because there have been many versions of this because of what I believe to be errors and oversights that I needed to correct. So I would like to read through it comprehensively and go over it verbally with myself and make sure that I don't think there are any holes right now, and if there are, then I'll probably address them with my mentor at this point, because I finally have a mentor for the Alaska Space Grant. Probably the apprenticeship is what I'm gonna create a proposal for. So I guess the first nitpick I would have with my own paper here is with the eventual intent of space applications. I don't really know if it's like scope creep or perhaps just unwise to specify to specify different applications, but like cast such a wide net with them. And I don't know if it's an overclaim or scope creep or something, but I don't know. I think it's okay because like the core idea is obvious. I want the inks to perform in extreme cold environments, including the Arctic and including space. So I think it's okay. They're printable because this is something I've learned that NASA cares about in my meetings with a NASA citizen scientist. This is what we're going to collaborate on in business. I think this is okay. It's quantified. It's clear. This is a little bit open-ended. However, the reason for that is because I don't actually know if the modified glass transition temperature will, goodness. I have a terrible migraine. I don't actually know if the modified glass transition temperature will increase or decrease. I don't really think I can make a claim as to either one, but I know what claim I want to make is for the performance. I think the hypothesis is pretty clear. It's quantified again. It's the same numbers. Clarify the terminology. I kind of restate the hypothesis, but I think I make it extra clear, because oftentimes when I'm speaking, I say things that people find very confusing and unintelligible, so make sure to do that. Proposed phase 1 R&D. Yeah, I think that's fine. I think all this up here is fine. I think the only thing I'm concerned about is maybe being guilty of scope creep or something. Manufacturing piezoelectric. I believe all that to be true. I don't think any of that is wrong. This is something that has remained completely unchanged throughout all the various versions of this document, so I have confidence that this is not wrong based on the literature I've read. This whole statement that cold-compatible piezoelectric manufacturing is relatively unsolved. Even though manufacturing piezoelectric materials compatible with robotic systems is somewhat emerging, it's completely novel in combination with this. This in and of itself is novel. I believe so. I name a specific application. It doesn't really delve into like like integration with drones or instrumentation for various purposes, but this was like the original purpose, and in fact, of course, this is what the conclusion is about at the end of the document. So even though I'm collaborating with people on other purposes, I think it's okay to elaborate on the purpose of robotics. I think that's okay. So this is something I wasn't sure about because when I initially structured this, it was for SBIR funding through NASA. However, I don't think this will be NASA SBIR fundable yet because obviously I'm not a small business entity this time. I intend to be in the coming college semesters, which I say at the end of this document. So I'm not even eligible to create an SBIR submission yet, and in order to become eligible, in order to become an operating business with research that I can submit, I need to get funding through something like the Alaska Space Grant. So I think the structure still works. I haven't taken as close a look at the proposal templates that I perhaps need to see for the Alaska Space Grant, or rather there's a presentation that I need to watch. But I think that the structure of the document around the phases of R&D is still acceptable. Even though this isn't the real document, of course, it's just something I made so that I can verbally go over my own ideas and also present them to people and make sure that they're intelligible and grounded in real physics. Yeah, okay, so I restate some things. I think this is fine. I mean, it's completely speculative because, of course, I don't truly know what I need to do in order to prove phase 1, so it's I can't really speak as to whether or not this is correct or incorrect, or whether or not I think it is. But it's what I came up with that I think will work. I think that's okay. I think this I'll be able to accomplish because I'm presenting at the Mind Exchange conference next month. Or I believe so. I would at least like to believe that opportunities like that will keep coming to me. I think this is okay. I think this is pretty grounded. This is not even particularly the novelty really lies in this. Like, as long as I have this formulation, it should be easy to fabricate it into this ink. Like, it's not really that big a deal once I have phase 1 proven to fabricate it into an ink. So it's not really that big of a concern to me whether or not the size here is correct or not, because it's pretty straightforward. And the robotics applications, I think this is where possibly the most holes could live. Because I kind of just like some of this just kind of came out of my ass like today. When I woke up, I was just thinking about like ferrofluidic robotics. A lot of it is inspired by quite random things, like I was in my geology for engineers class, and I was asked a question about the lack of cleavage that quartz has, if it's a coincidence that it's piezoelectric, which is not necessarily correlated, but there's something there, but it not because of that. But it allowed me to think about this. It led me down a train of thought that led me to think about like the AI and robotics I describe here. or rather machine learning, not really necessarily AI. Which is probably something I should have clarified in like my other video. Like what, of course, oftentimes when we say AI, we're really talking about machine learning. In this case, I'm probably only talking about machine learning. So this is, I'm definitely a little concerned about the applicability of this, but I do clarify, I was tentative enough to add this in closing. Feel free to ask me any questions. There's still questions I must ask. I also clarify this here. I think it was a good call for me to eventually elaborate on fluid containment. I don't know if it's actually necessary or not, but probably a good idea. I don't know as much about ferrofluidics as I do about piezoelectrics at this point. Piezoelectric materials. And polymer science and ceramic science and engineering. And perovskites and all of that. So I don't know as much about ferrofluidics, so it's a little bit tentative. But they're very fascinating. I'll probably dedicate a lot of research to them and learn a lot more. Yeah, so I think the document is okay at this point. Unless I come up with anything else I want to add, but I highly doubt it. I think if I come up with anything else, it's just going to overcomplicate everything. This is already kind of pushing it, perhaps. But I think it's okay. Yeah, so I think this white paper is okay. I think I can, or not white paper, pre-white paper. I think I can leverage this to start writing my, well, probably not my proposal. Well, perhaps I could write my proposal. I might ask my mentor. But it's so early in the mentorship, I don't really know when it would be appropriate to start or not. Yes, so I believe I can start writing at least a white paper. Perhaps a proposal for the apprenticeship